Donor is an atom that has a lone pair of electrons to share. Acceptor is an atom that needs electrons to complete its octet. Once formed, coordinate covalent bonds are indistinguishable from regular covalent bonds. Example, hydronium ion water molecule has lone pairs on oxygen. Proton has no electrons, acts as acceptor in formation of hydronium ion. Positive charge spreads over entire ion. All three oxygen to hydrogen bonds are identical in behavior. Example, reaction between ammonia and boron trifluoride. Ammonia has a lone pair on nitrogen. Boron trifluoride is electron deficient. Formation of coordinate covalent bond. Diagram showing lone pair from nitrogen to boron. Nitrogen donates its lone pair to boron. Coordinate bond is shown with arrow. Another example is ammonium ion formation. In ammonium ion formation, nitrogen of ammonia donates its electron pair to hydrogen ion. As a result, coordinate covalent bond is formed between ammonia and hydrogen ion. Other examples are protonated ethanol, ammonium chloride. Coordinate bonds are also called dative bonds. Important concept formation. Difference makes coordinate bond unique. After formation, behaves just like any covalent bond. When broken, both electrons return to donor atom. Coordinate bond formation practice. Draw coordinate bond formation in following. Check your understanding. Which compound is not able to form a coordinate covalent bond? Options are below. Summary coordinate covalent bond. One atom donates both electrons represented by an arrow, common in reactions involving H plus BF₃ AlCl3 formation, behaves like any covalent bond. Introduction to metallic bond. Metallic bonding explains the unique properties of metals. Metals show properties different from ionic and covalent compounds. This suggests the presence of a different type of binding force among metallic atoms. Properties of metals: shiny, metallic luster, high melting and boiling points, good conductors of heat and electricity, usually hard and dense, heavy, malleable and ductile, can be reshaped under pressure. All these properties are due to metallic bonding. Nature of metallic bond. Metals have low ionization energy, easily lose outer electrons. These free electrons move through the lattice, not attached to any one nucleus. Sea of electrons surrounds positive metal ions. Metallic bond definition. A metallic bond is a type of chemical bond. Positively charged metal ions are bound together by mobile, delocalized electrons. Electrons move freely throughout the structure. Strength of metallic bonds depends on number of positive charges on metal ions, number of mobile electrons donated by each atom. Example, sodium metal has 1 electron, leads to weaker bond magnesium. Metal has 2 electrons, leads to stronger bond magnesium, has a higher melting point than sodium. Stronger bonding due to 2 delocalized electrons explains higher melting point. Why metals conduct heat and electricity? Free electrons move rapidly through the metal. Electrons transfer energy efficiently. Metals are excellent conductors. Why metals are hard and malleable? Atoms in metals are arranged in layers, rows. Strong bonding keeps them tightly packed. Under pressure, layers slide over each other. Metals can be hammered into sheets or drawn into wires. In this table, comparison between metallic and ionic bond is shown in terms of types of atoms, electrons, structure, and conductivity. Which atoms form metallic bonds? Only metal atoms form metallic bonds. Examples: sodium, magnesium, iron, copper, aluminium. These metals share their outer electrons in the electron sea. Applications of metals. Metals are used extensively in industries, machinery and tools, automobiles and aircrafts, railways and rockets, buildings and bridges, electronics and electrical wiring, jewelry and household items. Electropositive character of metals. Introduction. Metals tend to lose electrons, form positive ions, cations. This property is called electropositive character related to the reactivity of metals. Definition: the tendency of an atom to lose electrons and form a positive ion typical of metallic elements. Highly electropositive metals. Alkali metals. Examples: sodium, potassium. Very reactive metals lose electrons very easily. React vigorously with water, gives hydroxides and hydrogen. React with halogens, give halides. Reacts with acids, give salts and hydrogen. Moderately electropositive. Alkaline earth metals. Examples: magnesium, calcium. Lose electrons less easily than alkali metals. Less electropositive. Less vigorous reactions with water and halogens.